Hello and welcome back to our VCC. Today we are going to start with the other part of theoretical distribution, and that is the Causal distribution. Yesterday we had discussed about the binomial probability distribution. Today it is going to be the Causal, and on the third day we will discuss about the normal probability distribution. Now yesterday we had touched upon what is random variable, what is continuous variable. It can be of two types. Continuous variable, it can be the random variable, it can be of two types, continuous as well as you have seen that discrete. So we first start with some discussions on random variable, then we go into the Causal probability distribution, and the next day we will do normal. As you know that the example of Causal and if you see the binomial, they are actually examples of discrete probability distribution, and normal distribution basically is a type of continuous probability distribution. We will also touch upon some of the problems in exercise 17 set A, B and C which are related to probability distribution, and we will touch upon many of the questions in additional question bank. We will also solve questions related to this particular distribution which has come in the May 2020 MTP. I would request you to keep your pen and paper ready, and at the end, of course, I will take the responses. I will share the responses to the questions which many of you have raised yesterday, some of the doubts which you have. Almost 92 queries have come and I have answered almost all of them. I have sent it to the Board of Studies that you will be able to view it in ECPL. Still, I will take some of the more important ones for discussion at the end of the session. So this is how we shall move today. And first, of course, is a quick recap of random variables. Now, some of you had some difficulty in understanding random variable. For example, Mahadevan K has requested me to take this topic once again. And as you know, that random variable means any variable which can take unpredictable values, which will take different values in different points of time, in different occasions. And we know that random variables are not completely predictable. It is not possible to predict random variables with 100% accuracy, plus you can say they are not deterministic. So that is basically what is a random variable. And as examples, we can talk about temperature, pressure, we can talk about speed, right? Speed of a particular vehicle, for example, crop yield, right? We can talk about the fact that rainfall. So these are different types of random variables, and random variables are broadly classified into two categories. The first, what we call as discrete random variable, and the second, what is known as the continuous random variable. Now, when we talk of continuous random variable, I am taking first continuous random variable. Now, a continuous random variable means it can take up any value within a defined range. Like as I said, if we talk about maximum temperature. Now, temperature is something which can assume positive values as well as negative values. I think there is one of our friend who was asking me yesterday that can I give an example of a parameter which is continuous and which can be negative also. Well, weight, for example, cannot be negative. Like I take one of the queries here, Jaisamir Kaur was asking me, she said that weight is an example of continuous random variable, but it cannot take negative values. Yes, it is true. Please note that continuous variable means any variable which can take any value within a defined range. So I will put it in this way. Please note that when we talk of random variable, it can be discrete or it can be continuous. Please note that in case of continuous random variable, it can take any value, but it has to be within a range. So please note this fact. So if a range is given, only within that range, continuous variable can take any value. Similarly, in case of discrete variable, it can take designated values. Designated, or I can say specific. It can take specific values within a range. So please note this difference between what is discrete variable and what is continuous variable. We discussed it yesterday, but since there is a query and since it relates to something which is very basic, that's why I am taking it first. So Jessamine, I hope you have understood that continuous random variable can take any value, no doubt, but only within a defined range. So this word range is very important. Similarly, for a discrete variable, it can take discrete random variable can assume specific values. For example, in case of Causal or in case of Binomial, we have seen that the experiments which we are conducting, for example, tossing of a coin or throwing of a dice, so these cannot have, they can only have specific values. For example, in case of dice throwing, you cannot have fractions. You can have either 1, 2, 3, 4, 5 or 6. No fractions. So we have to keep in mind that in case of discrete random variable, yes, the probability cannot be ascertained beforehand. There may be some in uncertainty in finding out the probability. But it is true that only designated specific values can be taken. For example, fractions. Maybe fractions, no. It cannot take fractions. Certain discrete variables cannot take negative values. So this is basically the difference between continuous random variable and discrete random variable. Now, can a continuous random variable be negative? One of our friend Ankit Sharma was asking this question. Well, Ankit, you can understand that I'll give the example of temperature. Now, temperature, if I take the example of temperature and vertical speed, temperature can be positive as well as negative. So, temperature is a continuous random variable which can assume both positive and negative. Right? Within a defined range. Okay. Similarly, vertical speed, say when an aircraft is cruising up, ascending during the ascent phase. Right? So the vertical speed is going up. So it is a plus vertical speed. When an aircraft is descending, it will have a minus vertical speed. So vertical speed, which is indicated by Vs, vertical speed can be both positive and negative, and vertical speed is an example of continuous random variable because it can take any value within a defined range. Please remember this word range, right? So I hope Ankit, Jessamine, you are clear with your ideas. Mahadevan also was asking about random variables. I am sure you have understood. Now we move on quickly to one more, example of continuous and random variable. Like we took the example of temperature, pressure, height, weight. Yes, height and weight can be definitely, ideally weight of course is positive, but height can be negative also. In other words, if you think of, say for example, the mean sea level, this is the sea level, right? Say an aircraft is flying, okay, an aircraft is flying at an altitude of say 35,000 feet, fine. So the height is 350, we call flight level 350, 35,000 feet. This is positive, height is positive, but when you consider the depth of the ocean, it can be negative also. Say for example a submarine which is cruising below the surface of the earth, within the territorial waters in the oceanic surface, maybe say 3,000 feet below the sea level, height can be negative. So you see, within a defined range, height and vertical speed can be both positive and negative. So they are continuous random variables and they can assume both positive as well as negative values. When it comes to weight, yes, it has to be positive. When it comes to the yield, that is the productivity of crops, productivity of minerals, definitely they have to be positive. Of course, in case of famine and other, when we have drought, there can be negative productivity, but ideally these are positive, continuous, random variables. On the other hand, something like coin tossing, as I said, or something like where you have exactly like number of defects, number of defective items, number of people who are coming inside a retail outlet. Okay, the probability of having 5 persons coming inside the retail outlet, number of cars which are coming in a petrol pump. So these are always discrete. They cannot be negative. They cannot assume fractional values. Okay, so I hope you are able to understand and appreciate the difference between what is discrete random variable and what is a continuous random variable. Both of them are random variables, which means that they will assume different values at different points in time on different occasions, and it is not possible to ascertain with 100% accuracy what will be the exact value which they are going to take. So there is some probability involved, there is some uncertainty involved, right? So this is what is continuous and discrete random variable. One of our friend Vasant also was requesting me. I hope Vasant now you are able to understand what is random variable and what is the difference between continuous and discrete random variable. Fine. We also discussed yesterday about some important properties of random variables. I will just quickly note once again those properties, and I request you to just follow what I would be discussing. First and foremost, any random variable, we discussed about probability mass function, and you remember that we have NCX, P to the power x, Q to the power n minus x. This is the probability mass function for binomial probability distribution, and the property number 1 is we know that fx has to be greater than equal to 0, but it will be less than equal to 1, but less than equal to 1. So please note that the probability mass function is nothing but the formula, this formula is the probability mass function. So we discussed in details yesterday about the binomial PMF. Today we shall discuss about the Quasar, right? The Quasar probability distribution and the probability mass function PMF for the Quasar distribution. So first, of course, is fx is greater than 0 but less than 1. The second one, please note, is sigma fx has to be equal to 1, which means that the value which x is going to take, say the variable x can take the values 1, 2 and 3. This means that function f1 plus f2 plus f3 has to be equal to 1. That means sigma fx is equal to 1. And we also discussed about 2 other parameters, that is mean and variance. So mean, you know, is denoted by mu. Mu is the mean, and mu here is sigma x into fx, where fx is this probability multiplied by the value which x can take, right? So this is the formula for mean. And in case of binomial, we have seen it is NP, right? And last is variance. Variance, you know, is denoted by sigma square. So this is variance. That means first and foremost that the probability mass function will be more than 0 and less than 1. Number 1. Number 2 is that it can assume many values, no doubt, but the sum of all those values, the function 1, f1, f2, f3 has to be equal to 1. The third is the formula of mean, which is nothing but sigma x into fx, where fx is the probability mass function and x is the value, individual value of x, right? X denotes the individual values. And finally, you have standard deviation, which is denoted by sigma, and therefore sigma square means the variance. So these are the 4 basic properties of any probability distribution, whether it's normal distribution, whether it's Quasar, or whether it's binomial. So now these are the basic raw materials we need to know. And now we enter into what is the next distribution, that is Quasar. right? It is spelled as Poisson, but then the pronunciation is Causal. It's a French. It is named after a French, mathematician who discovered this distribution for the first time. Now let us look at what is the difference between Causal and binomial. Now binomial we saw yesterday. Binomial distribution is used when you have two types of outcomes. Okay, it can be either success or failure. And we also saw that the probability will remain constant throughout. Now in case of Causal, like in case of binomial, we saw that in binomial distribution, typically examples would be coin tossing, right, throwing of a dice, for example. But then in case of Causal, we deal with rare events. Like for example, number of accidents, rare, something which is rare. So when we talk of Causal, the first one is it deals with rare events. Rare events, number one. And most importantly, the events will occur randomly. So please note, these are the important assumptions of Causal. First is it deals with rare events, rare within, within quote, within inverted commas. And it will occur at a constant rate. Constant rate. So these are the three basic features of Causal. And we approximated to binomial, B for binomial. So Causal distribution can also be modified into a binomial distribution form. So Causal distribution deals with rare events. It is dealing with random events, of course, and the events would occur at a constant rate, and the occurrence of the event does not change the possibility of it happening again. Which means if one event takes place, one customer walks into the showroom, it will not prevent another customer from coming in. That means the occurrence of one event will not hamper or will not influence or will not change the probability of it happening again. Right? So in that way they are quite independent. Now let us look at some of the examples. I will talk about almost 10 examples of Causal distribution. First one. Printing mistakes in a book. The rate of the distribution of printing mistakes. Let us take some examples now. First, printing mistake. Printing mistake in a textbook. So what is the probability that the textbook will have, say, 2 printing mistakes, 3 printing mistakes, 5 printing mistakes, 20 printing mistakes? So the distribution of such printing mistakes. So you have the number of mistakes, right? The number of mistakes, number, and the probability. 5 numbers of mistakes. Probability say is 0.2. 10 mistakes, say it is 0.3. 20 mistakes, say it is 0.25. Like this. So on. So this entire distribution, which shows you the number of mistakes and the probability of each of them. That means here, X, the variable, assumes the value 5, 10, 20, say 40, whatever, say 50. So X assumes all these values, and for each of the value, you have a probability. Okay? We discussed yesterday, and I hope you have remembered it, that this type of table is nothing but a probability distribution. So in case of Causal, the first example is number of printing mistakes in a textbook. Second is the number of meteorites which can hit the earth in a year. For example, NASA uses these type of mathematical distributions as part of their artificial intelligence tool through which they can predict how many comets or how many meteorites will come close to the earth, which we call near miss. So near miss means coming close, not hitting the earth, missing the earth by a few thousand or few lakh kilometers. Okay, near miss. Sometimes NASA predicts that yes, we will be having strikes. There can be a meteor or a comet which can come and strike the Earth. And what will be the size of such heavenly bodies, So this is through the Poisson distribution, and you know that binomial, Poisson and normal distributions are part of advanced financial modeling software through which predictions are made. Right? So these are highly practical papers and practical issues. Okay. So first is printing mistake. The second is number of meteors which can hit. Okay. The third example. So first is print mistake. Second is meteors. Okay. The third is number of road accidents. So number of road accidents. So you see, these are all rare events. Rare. These are not going to happen in normal life. Rare events. Road accidents. Next is the demand for healthcare. Healthcare. How many patients are looking for healthcare services at a given point in time? The demand per minute. Say what is the demand for a ventilator per minute? Now, under the COVID conditions, most of the patients who are senior citizens, who are elderly, require ventilator support. So at a point in time per minute, what is the quantum? What is the demand for ventilators? This is determined by the Poisson distribution. Number of clients visiting a ticket selling counter at a metro station. So number of clients. Okay, at a metro station. Number of passengers who are coming to buy their tickets, customers. So they are at a metro station. This follows Poisson distribution. Number of goals in World Cup match. Okay, so number of goals in a match, in a soccer match. Number of radioactive elements in a fusion process, in a nuclear fusion. Radioactive elements which are generated. The number of radioactive elements per minute. How many radioactive elements are generated per minute in case of a nuclear fusion? So you see, these types of data, these types of information is required both by the defense industry, the Ministry of Defense, as well as if you look at the nuclear power sector, the power sector also requires these type of information. So these distributions like binomial, like Poisson are used regularly by different agencies, by different institutions, by different industries. And that is why the examples, printing, number of meteor strikes, road accidents, demand for healthcare, number of clients who are coming to a metro, passengers, number of goals in a World Cup match. Then I talked about the number of radioactive elements. So these are all examples of Poisson distribution. Number of cyclones. Prediction of the number of cyclones in a year. This also follows Poisson distribution. So these are the applications. So we saw that Poisson distribution first of all deals with rare events. Rare events, you can see most of them are rare. Printing mistake is not ideally, it should not be there. It's a rare event. Meteor striking the earth, rare. Road accident. Demand for healthcare. Ideally we should be healthy. So the demand also shows something which is rare. Radioactive elements, cyclones, these are rare events. So when you see the problem, like some of you were asking that how do we know whether the question is on probability or whether it's on probability distribution. Friends, in most of the questions you will be getting, it will be mentioned in the question clearly that the distribution follows binomial or the distribution follows normal pattern or the distribution follows Poisson pattern. It will be given. And even if it is not given, if you see that the distribution is such which deals with rare events, then you can immediately apply Poisson distribution. If you find that the given question in the exam talks about coin tossing, talks about throwing a dice, that means the distribution to be used is binomial distribution, which has two outcomes, right? So from that perspective, this is how we talk about the examples of Poisson distribution. Now we look at the basic probability mass function of Quasar. So we have seen what is random variable. We quickly had a recap of discrete random variable, continuous random variable, and we looked at the features of the Quasar distribution, and it deals with rare events, it deals with random events, plus the events will occur at a constant rate. And we also saw that the examples, if you see, the examples come from different industries, and from defense to, if you talk about manufacturing, to the service sector, for example, number of passengers in a metro, the demand for healthcare, these are from the service sector. As well as the meteorological department also requires information like number of cyclones, number of meteors hitting the earth, striking the earth. So they are all examples of the application of Quasar distribution. Now we come to the basic probability mass function, which you need to remember. So just rub this out, and we now discuss about the probability mass function of this particular distribution. Now, who discovered this famous, of course, when we talk about this distribution, when was it discovered? Well, it was discovered way back in 1837, right? And it was discovered by Simon Dennis Causal, and you will be surprised to know under what condition this was discovered. Do you know, why this was discovered? Or after discovery of this probability distribution, what was it used for? Like I was speaking about number of meteors, number of passengers, number of mistakes in printing mistakes. You will be surprised to know that the Quasar distribution was discovered and it was used. First time, the first application was to find out the number of death caused by horses kicking. So you will be surprised to know the number of deaths caused by horse kicking. And this took place in the Prussian army. That means the probability distribution was used to find out what is the probability that two people will die due to the horse kicking them. A kick from a horse is deadly. It can be lethal. So how many soldiers were dying in the Prussian army during this time, 1837? So this actually was the basic application of the Quasar distribution, and it was discovered in 1837 by Simon Dennis Causal. So we are dealing with Quasar distribution, which basically has number of applications in different sectors, and now we will look into the formula. So this is the historical perspective, 1837, and it was discovered. The first application was to find out the number of death caused due to horses kicking the soldiers in the Prussian army. Now we go into the PMF, or the probability mass function. Okay. Now the probability mass function of the Quasar, let us see, PMF, is given by function x equal to e to the power minus m into m to the power x by x factorial. So please note, this is the probability mass function, that is the formula for the Quasar distribution. So please note, function of x, e to the power minus m into m to the power x by x factorial. You know x factorial. Why? What is x factorial? So 5 factorial means 5 into 4 into 3 into 2 into 1, like that. Okay. Now the probability, this is basically what is called the probability mass function, and what you see here, E. Now what is E? E is nothing but an exponential constant. Exponential constant. It is known as Euler's number. Euler was a famous mathematician. Euler's number, and the number is approximately 2.718. So for your problems which will come in the exam, you have to consider E equal to 2.718 approximately 2.71828. So we can take up to 3 places 2.718. So please note the probability mass function. Okay. So the properties, or if you see the features of Poisson distribution, is that the number of outcomes in unit time per minute, for example, the number of passengers coming in, or the number of defective units which I can discover, or the number of printing mistakes per page per unit time is independent, and the probability that a single outcome will occur during a short period is proportional to the length of the time. So basically this M which you see here, M can be broken into, if you look at the study material 17, I think it is 17.3. If you see there, you will get many of the applications which I was talking about and the properties. So this M is nothing but lambda into T, where T is the time interval. Unit time, that is per minute or per hour, whatever. T. Lambda, this symbol which you see here, this is called lambda, L-A-M-B-D-A, lambda. Okay, this lambda means the number of outcomes per unit time. So M gives you the total number of outcomes. So e to the power minus m, m to the power x by x factorial. This is very important, please keep a note of it, because we will use this formula for solving numericals, and of course, you can understand that x can assume the value 0, 1, 2 up till finite number. Okay? So it can take up any values. E to the power minus m, m to the power x by x factorial. And here again you can see that in case of binomial, we had 2 parameters. Binomial, we had 2 parameters n and p. But in case of Poisson, we only have 1 parameter, that is m. You have to remember only 1 parameter, that is m. Okay, so this is the probability mass function of the Poisson distribution. Now, let us look at, as I said, that E you have to remember is 2.718 approximately, and E we have come across E earlier. You may remember in differential calculus also we did ddx of e to the power x, and ddx of ex is e to the power x. So we have dealt with E earlier. E is the exponential constant. Also natural logarithms. E is the base of the natural logarithm. Okay, so you just need to remember the value of E. In most of the problems in the exam, the value will be given. For example, you have e to the power n. If m is 5, then e to the power minus 5. So the value will be given in the exam. So you don't have to worry on the value part. My only request to you is please remember this formula. Okay? Like for binomial, ncx p to the power x, q to the power n minus x. So here it is e to the power minus m, m to the power x by x factorial. Nothing else. You just need to remember this formula, number 1. Number 2, the feature of Poisson, that is it deals with rare events, and the fact that it deals with events per unit time. In case of binomial, there was no reference to time. How many outcomes? There the focus was that every experiment will have 2 outcomes, either success or failure. Here in Poisson, the idea is that the number of outcomes are linked with time. So how many passengers are walking in? How many customers are asking for service? How many people are looking for healthcare, say for example, healthcare support per unit time? Okay, how many meteors are striking the earth per year? So here everywhere the idea is to link the outcome with time. So I can write, one of the feature is that here the outcomes, please note that the outcomes are linked with time. Okay, So this is why if you see the study material also, you will see that this M has been broken into lambda into T, where lambda is basically the outcomes per unit time. Okay, average number of events in the given time interval. Okay. That means they deal with rare events, and ideally these events don't happen in real life much often. Like for example car accidents, right? Now say for example from the car accidents, if the government is able to find out that what is the probability that in an accident, in a car accident, 4 persons will die or 10 persons will die or 1000 persons will die, accordingly they can find out. If they know the probability distribution, if they find out what is the expected number of people who get killed during due to car accident, say they don't wear seat belts. As a result, they meet with a crash, they meet with an accident and they die. So through this, the government may be able to find out a solution by promoting the use of seat belts. So in this way, the Poisson distribution can be used. And please remember that 2.718 is the value. Sometimes theory questions come. Many of you are asking me whether theory questions keep coming. Well, for probability chapter as well as for theoretical distribution, if you see set A, B and C, set A mostly comprises of theory questions. So you may get theory questions. Out of 7 or 8 questions, 6 to 7 or maximum 8, you will be getting questions on theoretical distribution. So out of 6 or 7 questions or maximum 8 questions, 2 or 3 can be theory questions also. So please be prepared from all angles. You never know what questions will come. We can only make sure by practicing more and more questions, and we should also study theory questions because few questions on theory can be expected. For example, once we go into the exercises, you will find that a question can come that which distribution deals with rare events. They give you 4 choices, binomial, normal, Poisson and say uniform distribution. So your answer will be Poisson. Which distribution deals with success and failure, 2 outcomes. 4 options are given. Definitely your answer will be binomial. So few questions on theory can be expected. So please also go through these points which I am discussing. Okay. Now we go into some of the properties of Poisson. So I'll keep the formula here as it is because we will refer to this formula. Right? And we will go into the properties. So first of all, fx, this probability mass function which you see here, fx has to be greater than equal to 0. So first of all, I'll write that fx has to be greater than equal to 0. We know that probability is always a fraction. At most, it can become 1 and the least number will be 0. So it is greater than equal to 0. The second one is that the second property. So here we are dealing with the properties. The second property is that sigma fx will be equal to 1. Which means if you put x equal to 1 here, you will get f1, function 1. If you put x equal to 2, you will get f2. So in this way, f1 plus f2 plus f3 plus say fn, this total probability has to be equal to 1. So please note that sigma fx has to be equal to 1 and fx will be greater than equal to 0 and of course less than equal to 1. Right. Now, of course, we will look at the parameter of Poisson. Now, fortunately for us, we have to deal with only one parameter and the parameter is only 1. So only m. Once you know m, E you know the value. E's value is well known, 2.718. X will be given in the problem. So you only need to find m. M is the only parameter which you need to find. That is why, dear friends, please note that the Poisson distribution has only one parameter, so it is known as uniparametric. Uni means one. Uniparametric. This also comes as a question in the exam. I have seen this question coming in the last 2-3 years in the foundation exam, that which distribution is uniparametric? The answer is quasar, because in case of quasar only one, you need to know m. In case of binomial, it is biparametric, because you know in case of binomial, you have to know two parameters. You must know n and p. N is the number of trials, p is the probability of success in each trial. So you need two parameters. It is biparametric. But in case of quasar, only one parameter, you need to know only m. Okay? So the value of m is the only point where you have to work. X will be given in the problem, and the value of e you already know, and in all probability e to the power -1, -2, whatever be the case, the value may be given in the question. So it is a uniparametric. So please note the third property, it is uniparametric. Okay. Next is again a very easy point. Now in case of binomial also we saw the probability mass function. Here also we have seen the probability mass function. In case of binomial we discussed about the mean and the variance. So now in case of quasar also we shall discuss what is the mean and what is the variance. Now this is very easy for us because the mean in case of quasar is very simple to remember. It is m. Same value. Mean is m. Similarly, the variance, point number 5, the variance is given by sigma square, but the value is simple m. So you don't have to remember much. Okay, so the mean is m, the variance is also m, and it is uniparametric, and there is only one parameter, that is m, this m. Okay, so please note that like binomial, right? We have seen the probability mass function. This is the PMF, right? Like binomial, fx has to be greater than 0, less than 1. Like binomial, again the similarity is sigma fx has to be 1. So here also f1 plus f2 plus f3 up to fn is equal to 1. And last but not the least, the mean. In case of binomial, we had two parameters, n and p. Here we have one parameter m, and mean is m, variance sigma square is also m. So please remember and keep a note of these important information, because once we start with the numericals, this is a very short, small chapter and very compact, because all direct questions will come. In fact, majority of the discussion on random variable and the type of probability distribution we already did yesterday. So today it is a shorter, span of discussion, and most of the facts and most of the ideas you already know. What is randomness and what is discrete, what is continuous, you already know. So since we have already done binomial, quasar will be easy for you to understand. You only need to remember the probability mass function, number 1. Number 2, it is univariate. Number 3, quasar deals with rare events. Number 4, it deals with events which are linked with time. Lastly, the mean is m and the variance is also m. Now we go into mode. Yes, the last one is mode. So when you talk about mode, yesterday also we saw that binomial probability distribution is bimodal. There can be two modes. Here also it is bimodal. So number 6, property number 6 is mode. The last one is mode. So in case of mode, the largest integer which is contained in m, here the parameter is m. So the largest integer contained in m, if m is a non-integer. So if, say for example, m is say 6.5. If m is 6.5, non-integer, it's a mixed fraction, 6.5, that is 6.5. That means the mode will be the largest number which is contained within 6.5. So the mode will be 6. Okay, so this is the rule. So if the number m is not an integer, then the highest number which is contained in that integer, which is contained in that number, right? The highest integer which is contained in that number will be the mode. If the value of m is 9.7, if m is 9.7, it can be 9.7, it can be mixed. So in that case, what will happen? What will you write? You will write that the mode is the highest number, highest integer which is contained within 9.7, so it is 9. If the mode is 10.2, the highest number is 10. Okay, so in this way we shall determine the mode if m is not an integer. Now if m is an integer, in that case we will take m minus 1 as the mode. If m is an integer, then the largest integer, of course m minus 1, which is less than m minus 1 will be taken as the mode. So these 6 properties we have to remember. Once again, the first one is the probability mass function, e to the power minus m to the power x by x factorial. Just you have to memorize, no shortcut here, just memorize, and x can take any value, 0, 1, 2 and so on. Second is the fact that fx will be greater than or equal to 0. Third is that sigma fx, that is f1 plus f2 plus f3 up to fn has to be equal to 1. So number 1, 2 and 3. Parameter, it is uniparametric because we only need to find the value of m. If you know the value of m, you know the entire distribution. Therefore, here again it is uniparametric. This you need to remember. And fifth is the mean is m. Sixth is the variance is m. And seventh is that it has 2 modes. It is bimodal, very similar to binomial. It is bimodal. So if m is not an integer, then the mode will be taken as the largest integer which is contained in m. And if m is an integer, in that case we shall consider m minus 1 as the mode. So these are the basic properties and these are the basic information which you need to know about the Poisson distribution. Now we shall move into the last part before solving the problems, and that is we'll move into the approximation part. Okay. So I hope you are clear with this. It is once again quick recap. Poisson distribution is continuous or discrete. Is it a random? Is it based on random variable? Yes. For example, number of accidents, number of meteors striking the earth, number of mistakes in a textbook, number of deaths happening due to COVID, for example. Okay, so this cannot be predicted. So it is random. Okay. Number of the demand for healthcare services. These are random variables. So it is based on random variable. So we can say that the distribution is based on random variable. So it is a random distribution. First. Second, is the distribution continuous or discrete? Here it is discrete. Poisson is a discrete distribution. Why? Because here, in this case, all the numbers which are, we are concerned with, for example, number of mistakes, number of accidents, number of customers, they can only assume specific numbers within a given range. For example, number of customers cannot be negative. Number of patients in a hospital who are looking for healthcare support cannot be negative, cannot be fractional. So it is a discrete probability distribution. The PMF, the probability mass function, is given by e to the power minus m into m to the power x by x factorial. E is a constant known as the Euler's number. It is equal to 2.71828. We know that. And when we come to the properties, the first property is that the Poisson distribution deals with rare events. Number 1. Number 2, it is uniparametric. Number 3, the standard deviation or the variance is given by m. The mean is also given by m. Only one parameter is necessary and that is m. You need to know nothing else, only m. Plus sigma fx is 1 and fx will be equal to greater than equal to 0 and less than equal to 1. Plus the last one, it has two modes. It is bimodal in nature, and if m is not an integer, then we will consider the highest integer value contained within m, and if m is an integer, we will consider m minus 1. Last one is the distribution, Causal distribution, how we approximate, how can it be approximated to a binomial distribution. This is very important because questions will keep coming from this part also. So I am rubbing this part. We have discussed each and every point here, and now we go into the distribution, the approximation. So please give the heading. It is the Causal approximation to binomial. Approximation. Approximation to the binomial. Binomial. Binomial means, you know, some of you are asking me, I think I replied back also, what is binomial? Bi is 2. So binomial means two parts. Mathematical expression which has two parts, or which has two divisions, or which has two outcomes, like that. Okay. Now we go into the approximation. Now, the theory says, now if in case of a binomial, you have two parameters. You have n and p. Two parameters. What is n? N is the number of trials. And what is p? P is the probability. So n is the trial, number of trials, and p is the probability. Fine. Now please note very carefully. If the number of trials, that is independent trials, if the number of trials tends towards infinity, so let's understand this. If, condition 1, if n tends towards infinity, that means n becomes very large number, number 1. And number 2 is, if probability, the probability p becomes very small, that is, it tends towards 0. Okay, please note. So out of two numbers, n and p, one is becoming very large and the other is becoming very small. So they are product. Okay? The product. You know that in case of binomial, the mean is given by NP. If the product, please note, one of them is increasing very fast. N is a large number. P is a small number. N is moving towards infinity. N is tending towards infinity. And P is becoming very small. It is tending towards 0. So one number is going up like this. The other number is coming down like this, becoming lesser and lesser. So two opposing movements. One is going up, one is coming down. So the product will be somewhere finite, somewhere in between. Neither too large nor too small. So if one of them is becoming very large and the other is becoming very small, the product NP will be finite. Finite. F-I-N-I-T-E. Finite. That means it can be countable. It can be countable. So this is the condition. In this condition, please note, so when n is very large, so n is very large. N tends to infinity means it is very large. And p is very small. So large and small. When n is very large and p is very small, the combination becomes finite. The combination becomes finite. In this situation, only in this situation, please note that the binomial distribution containing n and p as the two parameters will be equivalent, okay, will be equivalent to a Causal distribution with parameter m. So please note, this is given in the study material also, 17.14, yes, formula 17.14. We have done the previous formula till 17.13. So this is 17.14. Please note. Once again, please review it, then we will discuss. So, we know binomial distribution is biparametric. It has n and p as the parameters. If you know n and if you know p, then you have the full knowledge about the probability distribution. Fine. Now, when n is large, it is tending towards infinity, becoming larger, and P is small. P is small. It is becoming smaller and smaller, moving towards 0. So when N is tending towards infinity and P is becoming small, their product will become finite. NP will become finite. Finite means countable. In that situation, only in that situation, the binomial distribution, which is given by B and P, binomial distribution with N and P as the parameter. These are the parameters. These are the parameters. Under this condition, B and P will be equal to a P. P means Poisson distribution with parameter M. So, you can understand here that M is N equal to NP. So, from this it naturally follows that M is equal to NP only in this condition. This is called a limiting condition, limiting. So, I will write here limiting condition. Limiting condition. Why limiting condition? Because this will take place only when N is moving towards infinity, becoming large, very large, and P is becoming very small. So it is a limit. There is a limiting condition here. Okay. So this is almost the end of the chapter, and now we will be ready to take some examples. Right. So we have seen the type of distribution. We have looked at the nature of distribution. It deals with rare events. So we took number of examples of Causal distribution. We saw the probability mass function. We have seen the properties, and now we see the last part. Properties again, you remember, sigma fx equal to 1. Fx is greater than 0, greater than equal to 0, less than equal to 1. We saw the mean is equal to M. The variance is M. And we saw the mode. It has two modes. And finally, we look at the situation where the Poisson approximation to binomial, where binomial will become close to Poisson. Causal. The Poisson approximation to binomial. So you can see the situation or the limiting condition where binomial will become Poisson and the parameters B and P will become P and M. So this gives us the complete knowledge of whatever we require for the exam purpose. Last but not the least, only one property is left, which is the additive property, formula 17.15 of the study material. So I hope this is clear to you, and once we do the problems and based on this formula, it will become even more clear and you will be able to do any problem on your own. Okay. So we move to the next one, that is the additive property. Okay. So additive property of Poisson. Let's look at the additive property. So if there are two distribution x and y, both are Poisson distribution x and y. X has the parameter M1 and y has the parameter M2. Both are Poisson. In that case, the rule says that x plus y as a whole will have the parameter M1 plus M2. As simple as that. So it is called the additive property. The additive property based on addition, additive property, which says x and y, x is a Poisson distribution with mean M1, with parameter M1. Mean means also variance. It's the same. Mean and variance, both are M1. So M1. Y is also a Poisson distribution with the parameter M2. That means the mean is also M2 and the variance is also M2. So x plus y, if you put z equal to x plus y, then x plus y will also follow Poisson distribution with the parameter M1 plus M2. So this you can see formula 17.15 given in the study material. So we are following the study material closely and we are covering all the information which we need to know in order to solve the problems in this particular chapter. Okay. Now we will look at some of the examples. The first example I am taking is an example which came in the exam. Of course, it was there in the MTP and it came in the exam few years back, few terms back. The first example I am taking. So just rub this part. So this is, I think, a light chapter because you don't have to remember many formula, only one formula, and no trouble regarding the parameters because the parameter only one parameter m, and the mean is m and the variance is also m, so you don't have to remember much. Okay, fine, we take the example. The example is like this. Passengers in a bus stop, passengers are coming in a bus stop and they follow a Poisson distribution. So passengers, they are coming to a bus stop and they follow PD, that is a Poisson distribution in short. Okay, and the rate is 4.5 passengers every quarter of an hour, every 15 minutes. So dear friends, please see once again the feature of Causal which I told you, that here the arrival rate is linked with time. So you see that the arrival rate is linked with time. Fine. This is the feature of Causal distribution. Okay. Now the question is, assuming a maximum of 20 arrivals in a quarter of an hour, calculate the probability of fewer than 3 arrivals in a quarter of an hour. Assuming the maximum of 20 arrivals in a quarter of an hour. So we are assuming that, let us take the first one. What will be the probability? So we are assuming 20 arrivals in a quarter of an hour. 20 arrivals in a quarter of an hour. What is the probability of fewer than 3 arrivals? So we have to find out the probability of less than 3 arrivals. That means x will be less than equal to fewer than 3. So x less than 3. You have to find out. So they are having, the rate is given 4.5 every quarter of an hour, assuming a maximum of 20 arrivals in a quarter of an hour. We can assume that, and we have to find out what is the probability that x is less than 3. That means the probability of fewer than 3 arrivals in a quarter of an hour. So here the unit of time, unit of time is quarter of an hour, 15 minutes. So it's 15 minutes. Okay. Now let us see the formula. Since we have to find x is less than 3, so basically it means we have to find the if you look at the factors here, the functions, f1, f0 we have to find, f1 we have to find, and f2 we have to find. Okay. So up to 2 arrivals. So in this way, if we find out P0 first, that is the probability, that is the F0, if you find out, this will be given by, F0 will be given by, we know the probability mass function is e to the power minus n into m to the power x by x factorial. This is the probability mass function. Now n we know, m is given. Okay, m is given 4.5. So using 4.5, we can find out e to the power minus 4.5 into 4.5 to the power 0, because x is 0. We are calculating f0. So x is 0 divided by 0 factorial. So in this way we can find out what is the value of f0. Similarly, we can find f1 and we can find f2. Okay, so calculation wise, this P0 which we see would come to around 0.012, and F1 and F2 we can calculate. If you calculate, it will come to, if you put this formula, P1 will come to 0.05 approximately, and P2 will come to 0.112 approximately. So if you add all these three probabilities, you will be able to find out the required probability that the question was, what is the probability that fewer than 3 arrivals will take place in the quarter of an hour? So we can find out the probability by adding this 0.05 plus 0.112 plus 0.012. This will give us the probability. That means we have calculated F0 plus F1 plus F2. And the probability mass function is this particular mass function which we have already discussed. Okay. Let's take another one. Okay. This is based on the binomial approximation to Causal. Okay. This is also an exam question. It came in the exam. So this type of question can be expected. This I have taken from a previous year question paper. Now, let's take the question. Calls are coming to your cell phone. Phone calls are coming to your cell phone, and it is following a Causal process. So phone calls are coming, and it follows a Causal process. This is given in the problem. The rate is 2 calls per hour. The rate which is given by lambda is 2 calls per hour. Please follow carefully. 2 calls per hour. What is the probability that if you forget to turn off your phone, okay, there's a movie, you are watching a movie, and the movie is 1.5 hours. Please see, the rate is 2 calls per hour. The movie is for 1.5 hours. If you forget to turn off your phone will ring when a call comes. So the probability you have to find out what is the probability that your phone will ring during this 1.5 hours. What is the probability that your mobile will ring during the movie? Let's see. What does it mean? Beautiful question came in the exam. Direct application of whatever we discussed. So you are given the rate. Please see the rate. 2 calls per hour. Fine. 2 calls per hour. You are also given the duration of the movie 1.5 hours. And what is the probability that your phone will ring? Your phone is going to ring during the movie. That means your phone will ring when a call will come. Okay. So basically, a call will come. Please listen carefully. A call will come, and then that is when your phone will ring. Fine. 1 call can come, your phone will ring. 2 calls can come, your phone will ring. So here, what you have to find out basically is, please listen carefully, the probability that X, that is the number of calls, X is greater than or equal to 1. Please see if you understand this point. This is a beautiful question. Very simple. Phone call rate is given. How many calls you are getting per hour on an average? It is known to you. It is a constant rate. 2 calls per hour is the constant rate. Lambda is 2 calls per hour. The movie has a duration of 1.5 hours. Okay? Now, what is the probability that your mobile will ring during the movie? The question here is, it follows a Causal distribution. So, if I say that the probability that the phone will ring during the movie means what? The probability that at least 1 call will come, at least 1 call. At least 1 call means X will be at least 1 and greater than 1. So I have used, you see how I am transforming the question into a equation, a sort of an equation. This is basically the strategy for working on these type of problems. You have to quickly understand the problem and transform it into a mathematical term. So I am trying to do it by trying to understand the call duration. The call frequency is given 2 calls per hour. The movie is 1.5 hours. During the movie, what is the possibility that your phone will ring? This is possible when I get at least 1 call. The phone will ring. So I am trying to find out the probability that X, which is the number of calls, is greater than or equal to 1. Okay? Now, how will you find X is greater than or equal to 1? So I can write this as 1 minus the probability that X is less than 1. Please see if this is correct. Greater than or equal to 1. This is the complementary event. For example, if I say that the probability that X is greater than 1 is say 3 by 5. The probability that X is greater than 1 is 3 by 5. That means the probability that X is less than 1 is how much? 1 minus 3 by 5. So the same thing I am doing here. I want to find out the probability here is X is greater than or equal to 1. So I am trying to find out what is the probability that X is less than 1. Once I know this, I will subtract this from 1 so that I get this. So I am moving in a reverse direction. Okay, please see, I am moving from this side to this side. Finding this probability is very difficult. So I start with the easier one. This is open-ended. I don't know how many calls I can get, but I can understand the complementary event. I am finding the complementary event that P equal to X greater than 1. X is greater than or equal to 1. The complementary event is that probability of X is less than 1. So I am trying to find this. Now X is less than 1. Once again, please use your common sense and your knowledge which you have gained so far in the last 2 sessions or maybe the last 3 sessions since we started with probability. Now, Quasar distribution, it is clearly given that Quasar distribution deals with discrete number. Phone call is discrete. Here we are dealing with number of phone calls. Okay. Now the question is, since we are dealing with number of phone calls, we can understand that phone calls cannot be fraction. Phone calls cannot be, say, 1.5 phone calls, I cannot say. Either 1 call or 2 calls or 3 calls or 10 calls. But I cannot say 6.5 phone calls, 3.4 phone calls, I cannot say. So, when I am saying that probability that X is less than 1, it actually means that probability when X is equal to 0. Please see whether you follow this. Please check. We have to find out that the phone will ring during the movie. Okay? That means at least 1 call will come. So I have translated this problem into a solution by saying that probability that the number of call X is greater than or equal to 1. That is what I am trying to find. But this is very difficult because number of calls I don't know. It can be 30, 40, 50, 60. So what I am doing is I am trying to find out the complementary event by trying to find out the probability that X is less than 1. And I will subtract this from 1. I think so far you are clear. Now my question is, X less than or equal to 1 means what? If I say that I have got a call, I have got less than 1 call. That means what? That means I have received no calls. Because number of calls cannot be fraction. It has to be a whole number. So if it is less than 1, it means basically that probability X equal to 0. So now, please think of the probability mass function. You remember the mass function is e to the power minus m, m to the power x by x factorial. And I think you will also remember that this m, which you see here, can be broken into lambda into t. I mentioned that, where lambda is the rate and t is the time. So in this given example, what you see here, in this given example, what I do is, I first find out m. What is m equal to? M is equal to lambda into t. Here the lambda rate is given. Rate is 2 calls. 2 into. T is 1.5 hours. Time is given. So 1.5. That is 3. 2 into 1.5 is 3. So I have done the first part of the solution. M is equal to 3. Lambda into t. Lambda is the rate which is given and t is the time. That is the duration of the movie. The movie is 1.5 hours duration. So by multiplying the rate into the duration, I get the total amount, the total number. So here m or the parameter is 3. So now I will put m equal to 3 in this formula. But I will do it for what? I will do it for x equal to 0. Because I have found out that probability that x is greater than or equal to 1 basically means 1 minus probability that x is less than 1. And since phone call, this particular problem is following Quasar distribution, in case of Quasar distribution, only whole numbers can take place. We cannot have fraction. Phone call cannot be negative. That means within a defined range. The range is 0 onwards. Please note, it is not less than 0. The range is given. Within the range, it can only occupy whole numbers, integer numbers, whole numbers, no fraction. So in this case, I can understand x less than 1 means x equal to 0. It has to be 0. So I will put this value. Let us see what I get. So m is equal to 3. Okay, so I will just put m equal to 3. So I will write here. So 3 to the power, the formula is e to the power m. So I will write e to the power m. M is 3. M is 3. So e to the power minus 3 into m to the power x. M is 3. So 3 to the power x. But x is 0. So I will write 3 to the power 0. Divided by 0 factorial because x is 0. Okay. Now we are getting, what are we getting? We are getting 3 to the power 0 is 1. Factorial 0 is 1. So this is equal to e to the power minus 3. E to the power minus 3. E to the power minus 3, if you calculate, it will be, how to calculate e to the power minus 3? E to the power minus 3 means 1 by e to the power 3. We know the value of E, so this is equal to 1 by 2.718 to the power 3. If you calculate, let me just calculate and see. You can try and see, it should be coming to 0.05. It will come to around 0.05 approximately. You can just 2.718 into 2.718 into 2.718. Okay, this gives me 20.07. So now if you try 1 divided by 20.07, it gives you roughly 0.04982. 0.04982, that is roughly equal to 0.05. So I have written 0.05. Please note, what have I found out? I have now found out this part. Okay? So my answer that the phone will ring, that is x is greater than or equal to 1 will be what? 1 minus this, and this part is 0.05. So the answer is, the required probability is 1 minus 0.05, that is 0.95. This is my answer, this is my probability. 0.95 means 95%. So there is a 95% chance that the phone will ring during the movie. While the movie is going on, during that 1.5 hours time, the phone will ring. I hope it's clear. It's a lovely example. I mean, as I say that I deeply appreciate and deeply respect the way in which the beautiful questions are being set by the Board of Studies and by our expert panel of examiners. Lovely question. I took a lot of time to explain because I am doing it for you for the first time. But when you do it now, when you do this problem now on your own, you don't have to explain anybody in the exam. You just see the problem, apply the logic, complete the problem. So it will take maybe 1 minute or 1.5 minutes max to solve this type of problem. Okay, so I hope you can see the type of problem which you can expect. It's a very, very important problem for your exam. And you can see that phone calls follow a Causal process we have seen, and we have been given the rate. And I already told you that the rate is important because the rate into time, lambda into time, m is equal to lambda into time. Lambda is given, time is given, lambda is given. 2 into 1.5 gives you m. So you have got the parameter. We know that Causal distribution is uniparametric. Only one parameter is required. So once you get it, remainder part of it, you transform it into the equation 1 minus this, and from there you find out the answer comes to 95%. I think it is clear to you and you have been able to follow. Okay. And if a question comes, fine, 95% chance that the phone will ring. Now, how many phone calls do you expect during the movie? How many phone calls do you expect during the movie? This is the fact that 95% chance that the phone will ring. But how many phone calls will you expect? So, mathematical expectation. We know expectation means mu. That is mean. Mu is nothing but mean. Here, in case of Causal distribution, the mu is m. M we already found out, 2 into 1.5, which is 3. So the answer is, expected is 3 calls. Okay. So now, if you go to a movie hall, and you know that the rate of your phone call, your incoming call, you can, even if you put your mobile on silent mode or on vibration, so you can now think like, Newton and Sir Isaac Newton, and you can think like people like Causal, great mathematicians, and you can predict. You can actually, if you go with your family members or with your friends, you can surprise them by saying that, look, I can predict how many calls normally you get. With that information, if you go to watch a movie, even if you put your mobile in silent mode or vibration mode, you can predict with almost, let me take 17.12, we'll take 2-3 examples, then we'll move into the exercises. Okay. Most of the work we have already done yesterday, so today we are focusing only on Causal, and we are looking at the features of Causal, the properties of Causal, and of course, the probability mass function. So, the probability that a random variable x follows Causal distribution, what is the mode of the distribution? So, here if you see, probability is given, what is the mode of the distribution? Okay, just a sec, let me take first, 17.11 is there. Okay, let me take 1 first, 17.11. 17.11, the first example. Find the mean and standard deviation of x where x is a Causal variate. It is a Causal variate satisfying the condition probability x equal to 2 is equal to probability that x equal to 3. Okay, let us take this. Okay, so we can understand that the probability mass function PMF, the probability mass function is given by e to the power minus m, m to the power x by x factorial. This we know. This is the standard formula for the Causal distribution. Now, Px equal to 2, that is probability when x equal to 2 is given by function 2. This is equal to function 3, f equal to 3, f of 3. So this means, let's put this value in the given PMF. So what do we get? Let's put x equal to 2. So e to the power minus m, m to the power 2 by 2 factorial. This will be equal to f3. That is e to the power minus m, m cube by 3 factorial. Now if you, let us go and let us see if we can further simplify this. So this means e to the power minus m, m square by 2 is equal to e to the power minus m, m cube by factorial 3. That is 3 into 2 into 1, of course. 2 cancels out. Okay. E to the power minus m, e to the power minus m cancels out. M square cancels out, only M remains. So we are getting M is equal to 3. This is the answer we are getting, M equal to 3. The question was find the mean and the standard deviation. We know in case of Causal, the mean is equal to variance equal to 3. So we have got the mean as 3. Now the standard deviation we have to find out. So this is number 1, mean. We know mean is equal to variance. In case of Causal, both are 3. So standard deviation. You know standard deviation means square root of variance. So it is square root of 3. It will come to around 1.73. Okay. So this is the first problem which we are doing. We have done. So probability X, this is a very similar type of problem which has come in the exams. So very, very likely to come in the exams. And you can expect this type of, numerical. So be ready for this type of numerical. So just put the value X equal to 2 in the equation. Here we have put X equal to 3. So you can see 3 here, 2 here. Now we just eliminate and you get the value M equal to 3, where M is the mean. We also know that in case of Causal, the variance is also M. So both are 3. So since variance is 3, standard deviation is square root of variance. So root 3, that is 1.73. Okay. Let us take, let's take number 17.16. Let's see this one. 17.16. And see if we can solve it out. Okay. 17.16. Please move to 17.16. If 2% of electric bulbs manufactured by a company are known to be defective, 2% is defective. Okay. 2% is defective. Please see the type of examples from this. You will understand the applications of Causal distribution. Okay, so what is the probability that a sample of 150 electric bulbs taken from the production process would contain exactly one defective bulb and more than 2 defective bulbs? Okay, so we know 2% normally are defectives. What is the probability? So we have to find out the probability that a sample of 150 bulb will contain exactly one defective bulb. Okay. So it will contain exactly one defective bulb, and second one is more than 2 defective bulb. Number 2 is greater than 2 defective bulb. This is what we have to find out. Okay. So in this particular example, you can see that we have, in this case, we have the probability is given 2%. So I can write M, probability P is equal to 2%, that is 2 by 100. Okay, 2%, that is 1 by 50. Fine. And we have seen that bulb number is given, number of bulbs which are taken at random is given. So this is nothing but N. N is equal to 150. So you remember the discussion which I did today on the particular point, binomial approximation to Causal. When N is large and P is small, I discussed about the fact that binomial probability distribution will approximate itself to Causal. So in this case, what will happen? N into P, we will follow M is equal to N into P. That is, N is 150 and P is 1 by 50, 1 by 50. So M becomes 3. So if M is becoming 3, we have to find out one defective bulb. At least the first question is exactly one defective bulb. That means we have to find the probability that X is equal to 1. And now we know that the parameter M is 3. M is 3. So what is the probability that X is equal to 1 when you know that the parameter M is 3? So I will write the probability mass function e to the power minus M into M to the power X by factorial X. This is equal to e to the power minus 3 because M is 3, M is 3. So e to the power minus 3 into 3 to the power 1 because x is 1. So 3 to the power 1 by factorial x is 1. So factorial 1. So this is e to the power minus 3 into 3. If you calculate, it will come to approximately 0.15. It will come to 0.15. That means a 15% chance of having one defective in a lot of 150 bulbs which are taken at random. So this is the first part. Now we will do the second part, that it is greater than 2. The number of defectives will be more than 2. So I think the first part you have followed. I am sure you have understood. Okay. Now we take the second part. Now the second part is the probability that there will be more than 2 defective bulbs. Okay. So I can write the probability that x will be more than 2. So it is greater than 2. This is what you need to find out. Now greater than 2, whenever you get this type of expression, you see the last one which I did on the phone call. There also what I did was I proceeded to find out the complementary event, the complementary probability. Same thing you have to do here. So probability that x is greater than 2 is basically equal to 1 minus probability that x is less than equal to 2. You see, this is very similar to the idea we developed together when we discussed about Venn diagram. You may remember that complementary set. So this is A. What is the complement of A? The shaded part. Same thing here. Okay, so we have to find the probability that x is less than equal to 2. X is less than equal to 2 means what? X can take the values 0 or 1 or 2. The range is 0 to 2. Range. Okay, so what we will do here is we will now find out F0, F1 and F2. F0 will be what? Just let us put the value e to the power minus m minus 3 into 3 to the power 0 by 0 factorial. F1 will be e to the power minus 3 into 3 to the power 1 by 1 factorial, and F2 will be e to the power minus 3 into 3 square by 2 factorial. Now if you solve it, you can get e to the power minus 3 into 3 to the power 0, this is 1. 3 to the power 0 is 1, this is 1. So you only have e to the power minus 3. Here also you will get 3 into e to the power minus 3. Because 3 to the power 1 is 3 and this is e to the power minus 3 is here. F2, function of 2. Function 2 will be e to the power minus 3 into 3 square is 9. 9 by 2. So if you add all of them, that means if you are going to add F0 plus F1 plus F2, you will arrive at the value 0.5768. 0.5768, which is roughly equal to 0.58. Okay, so these are two of the problems which we have done. Okay, now lastly we look at the fitting of Causal distribution. Now there can be a situation, of course, these type of problems are rarely going to come in the exam because these are long problems. The problem which I am about to share, fitting of a Causal distribution. Now fitting a Causal distribution. Okay. Now we know that Causal distribution is uniparametric. Uniparametric. That means it has only one parameter m. Only one parameter m. Fine. So, if you are given a frequency distribution, now you know what is frequency distribution, I am not going into that, you already know that different value with the frequencies. If you are given the values and the frequency, from there you can easily find out the arithmetic mean. Now once you get the arithmetic mean, that is denoted by x bar, if you equate that with m, then that frequency distribution can be transformed into a Poisson distribution. So once say X bar, say the frequency is given, say just say 10, 12, 18, 19, 25. These are the number of the numbers, and the frequency that it is 10 is 5. Frequency is given 5, 7, 6, and say 10. So from here you can find out the weighted figures, and from there you can find out the weighted average, basically the mean. Once you have the mean, that is given by X bar, so you know Fx, sigma Fx by n, that gives you the mean. So you know X bar. X bar, if you equate it with m means the m which you get in the Quasar distribution. So once you do it, this entire frequency distribution will now approximate itself. It will become a Quasar distribution with the parameter n. So that means now you can find out the distribution. You will write e to the power minus m, m to the power x by x factorial, where this m which you see, I will denote it like this, m bar. So this is nothing but the derived value of m which you have calculated from this frequency distribution. Okay, so this is how you fit. You are fitting a Quasar distribution based on a frequency distribution. Both are different. One is frequency distribution, where numbers are given and the frequency is given. From there, you are transforming it into a probability distribution where you will get the numbers and the probability. Frequency distribution deals with numbers and the frequency. Here you are dealing with the numbers and the probability. Okay, so this is how you transform a frequency distribution and you fit a Quasar distribution based on the X bar, that is the weighted average, which you derive from the frequency distribution. Fine. Now the last part, it is probably not included in the study material. I think I'll just check once again, but I have seen that few questions have come in the exercise. So we will spend the last 5 minutes on the last part, that is skewness. Okay. Few questions are there. That's why I think it is safer for us to discuss. This is the heading. Please give the heading skewness. Very, very important. Skewness. Skew. What do you mean by skewness? Well, skewness means the distribution, the graphical way in which you depict the distribution. Now, skewness means, lack of symmetry. So, skew. If I say that the distribution is skewed, that means it is biased. Skew means bias. Skew means lack of symmetry. Lack of symmetry. Okay. Lack of symmetry. Now, I'll give an example. There are two types of skewness. One is called a left skew, left hand side, and the other is right hand skewness. Now, if you talk about left hand skewness, let us draw the graph. Left hand skewness means that it is negative skewness. So, left hand skewness means negative and right hand skewness means positive. Please note this. So, left hand skew, that is negative skewness, will be shown like this. The graph will be like this. Okay, the slant is towards, it's the left hand. Skew is towards the left side. Okay, negative skewness. In this case, what will happen? The mean will be here. Mean first. Mean of the observations. The median will be in the middle. Median. And the mode will be here. Okay, this is called left hand skewness, LHS. This is a negative skewness. Negative skewness. Now I will draw positive skewness. So you can understand positive skewness will be towards this is towards the right. Positive skewness will be towards the left. So if I draw a positive skewness, skewed distribution, it will be like this. Okay. So in this case, mode will be first. Mode. Okay. Then you will have in between median. And then here you will have the mean. Okay, so this, dear friends, is what we call a positive skewness. Please check once again. This is a right hand skewness. Okay, this is left hand skewness, because the left side, on the left side you have the slope coming down, left side. Here you have the slope on the right hand side. It is sloping downwards. The curve is sloping downwards on the right hand side. So it is called a right hand skewness, also called positive skewness, and this is negative skewness. Okay. Now if you combine them together, or if you think of the ideal distribution, okay, next day we will do normal distribution. You will see that the normal distribution has no skewness. That means the normal curve, I will just draw the normal curve here, you will understand. In case of the normal curve, you will find no skewness. The normal curve is like this. In this case, what is going to happen? It is symmetric. It is symmetric because the same line represents the mean, the same line represents the median, and the same line represents the mode also. Please note. So three diagrams are there. Diagram number 1, diagram number 2, and diagram number 3. The first diagram is non-symmetric. Some questions are there. Non-symmetric. We call it asymmetric. Okay, you will see this term. Asymmetric. Asymmetric. Asymmetric means lack of symmetry. Symmetry means, it should be same on both the sides. Like symmetric letter. Okay, I can say A is a symmetric letter. Because if you bisect A, it is symmetric on both the sides. O is a symmetric letter. E is a symmetric letter. Line of symmetry is this. But if I say Q, is it symmetric? No, it is not symmetric. Okay, if I say X is symmetric. Y is symmetric. But if I say G, is it symmetric? No, G is not symmetric. So you see, this is asymmetric, lack of symmetry, and we have a negative, skewness, because the slope is towards the negative side. In this case, the distribution, this graph is what? It is the graph of a distribution, probability distribution. So this probability distribution number 1 has a negative skewness, and it is called, in case of negative, it's a negative, it is a left hand. The slope is towards the left. So left-sided skewness. This is a positive right-sided skewness, and in the diagram 3, this is the normal distribution curve. We will do it on the last day, my last session with you on 22nd, I think. Okay, so then there we will do the normal distribution. The normal distribution is just like this. It can be a curve like this, it can be a curve like this. But in both the cases, the mean, median and the mode will be the same line. So it is symmetric. Because the mean, median and mode is in midpoint, midsection. All the three parameters, mean, median and mode, are in the same line. So it's totally symmetric. Okay, so this is basically what we need to know. Now the question, why I am discussing this, if a question comes, whether Poisson distribution is, what type of, is it symmetric? Is it negative symmetry or is it positive symmetry? Now, it has been seen that Poisson distribution is positive. So the symmetry, if you see the Poisson distribution is more like right hand, please note, it's more like right hand side symmetry. So it is a positive. Poisson is, the skewness is positive. Poisson, the skewness, it is positively skewed. So it is not symmetric, it is asymmetric, but the graph will be more like this. The right hand side, the slope will come. Okay, so this is the graph of the Poisson distribution. And just for those of you who are more inquisitive, if you want to know more, please note that the skewness, in case of Poisson distribution, the skewness is, the formula is coming to 1 by lambda, square root of lambda, 1 by square root of lambda, which is positive. So it is more than 0. 1 by square root of lambda is the quantum of skewness. The skewness quotient is given by 1 by lambda. 1 by lambda is greater than 0 because it's a positive number. Lambda has to be positive. So it is more than 0, greater than 0. So fine. So now with this we go into MCQ and we start with set A. Okay. So I hope the entire discussion you have followed. We started with the features of Quasar distribution. We talked about the historical background. We talked about number of applications of Quasar distribution. Then we talked about the probability mass function, the basic properties of this distribution, including uniparametric. It deals with rare events. We have only one parameter, that is M. M is the mean. M is also the variance. I also discussed about the mode. It has two modes. Plus, we discussed about the additive property. If X and Y are both Quasar distribution, if the parameter is M distribution with the parameter M1 plus M2, right? And we also saw the probability mass function in detail. I now go to MCQ set A. So MCQ set A, I'll take few questions. Number 8. These are, many of them are theory questions. Number 8. The important characteristics of Bernoulli trials. Please see the outcomes, the different alternatives. Each trial is associated with two possible outcomes. The trials are independent, the trials are infinite, and option D is both A and B. Now I discussed yesterday about Bernoulli's trial because Bernoulli's trial or Bernoulli's process is the basic understanding is required in order to know about probability distribution. We discussed it yesterday, and you remember that Bernoulli's trial, Bernoulli's process means a process which has two possible outcomes, plus both the trials are independent of each other, right? So in the case of 8, question number 8, option number D will be the right answer. A condition of Quasar. Which one is not a condition of Quasar? Please see that number of theory questions are coming, so it is important to go through these as well. First one, the probability of having success in a small time interval is constant. Okay. Second one, the probability of having success more than one in a small time interval is very small. Option B actually is technically correct. I mean, the fact given in option B is correct. Option C, the probability of having success in a small interval is independent of time and also of earlier success. This is also correct because this is one of the basic parameter or the property. Both B, C and D are technically correct. But here the question is which one is wrong? Which one is the odd man out? So option number A. Option number A is the odd man out. A is the answer in this particular case. Okay. Let's take number 21. Which one is a uniparametric distribution? Number 21. Which one is a uniparametric distribution? Definitely you have 4 options: binomial, Quasar, normal, hypergeometric. Only if you take the case of Quasar, it is uniparametric. Binomial has 2 parameters. Normal distribution, when we do it on the last day, you will find even for normal distribution there are 2 parameters. So uniparametric is Quasar. So 21B is the right answer. 22. For a Quasar distribution, option A, mean and standard deviation are equal. No. Option B, mean and variance are equal. Yes, this is correct answer. Because mean and variance both are given by M. 23 I am taking up. Okay. Quasar distribution may be unimodal or bimodal or multimodal. We have already discussed in detail that Quasar distribution, like binomial, has 2 modes. It is bimodal. So 23, option number B is correct. 24. Okay, 24. Quasar distribution is always symmetric. Option B, always positively skewed. Option C, always negatively skewed. Option D, symmetric when M equal to 2. So dear friends, you can see this is the reason why I completed the section on skewness and on symmetry through the graph. So you may remember I showed you 3 pictures, 3 graphs. I drew 3 graphs. One to show negative skewness, one to show positive skewness, and the third one is the normal curve, which is symmetric. So you remember I discussed that the probability distribution typically Quasar has a positive, skewness. So therefore it is always positively skewed. 24 option B is correct. We take number 25. Okay. A binomial distribution with parameters n and p can be approximated by a Quasar distribution with parameter m equal to np when n tends to infinity. Okay, correct. Technically correct. P tends to 0. This is also correct, but partly correct. Number 3 is, I think, n tends to infinity and p tends to 0. This is also partly correct. Fourth one, n tends to infinity, p tends to 0, so that np is finite. This is the right answer, because for binomial approximation to Quasar, n should be tending towards infinity and p should be tending towards 0, so that np is finite. So for 25 the option is D. Okay. 26. For Quasar fitting to an observed frequency distribution, what we have to do? I took the last part, frequency distribution. I took the mean, weighted average, sigma fx by n. I equated that with m. M is the parameter for Quasar, which we have seen. So what to do? 26. Option number 1. We equate the Quasar parameter to the mean of the frequency distribution. This is the right answer. So 26 will be option A. Now I go to set B. So we have taken 1, 2, 3, 4, 5, 6, 7, 8 questions of set A. Now we take set B. If the standard deviation, okay, so let's take set B. Fine. We take set B now. In set B, we have, if the standard deviation of Quasar variate is 2, what is the probability that x is greater than equal to 1.5 and less than equal to 2.9? Okay, the standard deviation is given 2, SD is given 2. The question number is number 9. Set B number 9. Please check the question. Set B number 9. Okay. Set B number 9, standard deviation is 2. That means variance is 4, and variance means m. Fine. What is the probability that the probability x is more than 1.5 but less than 2.9? It means what? Quasar distribution is a discrete probability distribution. Discrete, not continuous. So, if you have a score more than 1.5 and less than 2.9, it means what? The only possibility is that x is equal to 2. So, I will put x equal to 2. So, what I will do is e to the power minus m into m to the power 2 by 2 factorial. This is going to be the formula. Right? So, if I put it like this, e to the power minus m, here m is 4. So, e to the power minus 4 into 4 square by 2 factorial. So, if you calculate it, it will come to 0.144. So, option number D is correct. Number 9. Okay. I am taking number 10. If the mean of a Quasar variable x is 1, the mean is 1. What is the probability that x takes the value of at least 1? What is the probability that x takes the value at least 1? That means x is at least 1. So it is what? It is greater than equal to 1. At least 1 means it is greater than equal to 1. So here what I do is, I will take the complement. What I will do is complementary set. So I will first find out the probability that x is less than 1. Whatever the probability is, I will subtract it from 1. 1 minus this. This will give me this number. So accordingly, x is less than 1 means what? X has to be positive. It is less than 1. So the only value it can take is 0. That means this is equal to 1 minus probability that x is equal to 0. X is equal to 0. I know mean is 1 and Quasar distribution is uniparametric. So once I know m, I can easily find what is the value of x equal to 0. E to the power minus 1, m is 1. So e to the power minus 1 into 1 to the power 0 by 0 factorial. this will give me e to the power minus 1. That is 1 by e. 1 by e, let us calculate 1 by e, that is 1 divided by e, that is 2.718. It comes to 0.3679. So 0.3679. Fine. But I need to know 1 minus p. I have got this value. So the actual probability which I need to find out is 1 minus 0.3679 and this is equal to 0.632. 0.63208. So it is 0.632. Let's see the options. Number 10, please check. Option number C is correct. 0.632. So option number C is correct. So we have done 9 and 10. Okay. Okay. So let's take the next question. We are taking number 13. Set B number 13 quickly. I'll grab this part. 9 and 10, I think you have understood and followed how we are solving the problems. Okay. I've also taken number of theory questions because you can see the importance of theory questions. Number 13. Okay. For a quasi-variate where P probability x equal to 1 is equal to the probability that x is equal to 2. What is the mean of x? Okay. What is the mean of x? Please check this. So here, e to the power minus probability that x equal to 1, e to the power minus m into m to the power 1 by 1 factorial is equal to the probability that x equal to 2. So what is the probability mass function? E to the power minus m into m square by factorial 2. So now let us see. So e to the power minus m cancels with e to the power minus m. So what I am getting is m cancels with m. So I am getting m is equal to factorial 2, that is m is equal to 2. The question is, what is the mean of x? We know m means the mean. So the answer is 2. Option is C. Number 13 answer is C. I am taking number 14 now. This is also a lovely question. If 1% of an airline's flights, you can see the direct application in aviation sector. If 1% of an airline's flights suffer minor equipment failure in an aircraft, what is the probability that there will be exactly 2 such failures in the next 100 such flights? The hint is given in the problem. You don't have to worry. The hint is clearly given. Please see that the number n is given. So, in this case, number 14, we have to use the binomial approximation to Causal. Okay? So what we do is, for 14, question number 14, it is given, please see the question once again, 1% of an airline's flight suffer minor equipment failure. So the probability is 1%, P is 1%, that is 1 by 100, 0.01. Okay, fine. Now it is given that 100 such flight, so n is 100. In binomial, you know, binomial distribution, you know that the parameter is mean. Mean is given by n into p. So here n into p is, n is 100 into p is 1 by 100. This 1 by 100, that is 100 into 100, 1. So m equal to 1. Since n is large, n is 100 and probability p is very small and np is finite, np is 1 which is finite. So we are satisfying all the conditions of what? Binomial approximation to Causal. So this binomial distribution which you see here can now be approximated by a Causal distribution, which means now we can find, the question says there will be exactly 2 failures. That means we now have to find the probability that x equal to 2 and we will not use binomial, dear friends, we will use Causal. Now Causal we will use, so e to the power minus m, m is 1. So e to the power minus 1 into 1 to the power, m is 1, 1 to the power x, x is 2, so 1 square by 2 factorial. So this is f2. So if you work it out, it will come to e to the power minus 1 by 2. So that means 1 by 2.718 into 2. So let us just find out what is that going to be. 1 divided by 2 divided by 2.718. It is coming to 0.1839. 0.1839. I am getting the answer 0.183958. It is coming to 0.183958. That means it is approximately equal to 1.184. 0.184. 0.184. Let us see the options given in the problem. Yeah, we have the option B. Okay, 0.184. Therefore, number 14B is correct. Okay, I hope you are able to follow the way in which we are solving. I now move to set C. Set C. Okay, I'll take set C now and we will check some of the problems there. Okay, so set C. Set C, I will take the first, I'll take the second 2 problems. Let's check taxi drivers. Let me take number 14. Okay, the number of accidents in a year attributed to taxi drivers in a locality follows Causal distribution. Fine. With an average of 2. So with an average of 2 here means M is equal to 2. Out of 500 taxi drivers of that area, what is the number of drivers with at least 3 accidents in a year? So the idea is probability that X is at least 3. Probability that X is actually at least 3 means the probability that X is greater than equal to 3. This we have to find out. You know M equal to 2, it is given. Number of taxi drivers is also given, that is 500. So we have got 500 taxi drivers. 500 taxi drivers and they follow Causal distribution with an average of 2. So we have to find the value or the number of taxi drivers in whose case there are at least 3 accidents in a year. So out of 500 taxi drivers, how many drivers are responsible for at least 3 accidents in a year per person, that way. Okay. So we have M equal to 2. So we have to find the probability that X is greater than equal to 3. In other words, we will use the complementary relation and we will find out the probability first that X is less than 3. And once we get this, we will subtract this from 1. So we will do 1 minus probability that X is less than 3. This is what we shall do. Now, X is less than 3 means what? X is less than 3 means that X can assume the values 0, 1 and 2. X is less than 3. So we have to find F0, we have to find F1 and we have to find F2. Fine? So we have got F0. F0 will be equal to what? The PMF is e to the power minus m, m to the power x by x factorial. So e to the power, function 0, F0 will be e to the power minus m. Now m is given 2, minus 2 into 2 to the power 0 by 0 factorial. F1 will be e to the power minus 2, 2 to the power 1 by 1 factorial, and F2 will be equal to e to the power minus 2, 2 to the power square by 2 factorial. Now if you calculate and if you add up all of them, we are getting 0.677. So if you add all of them, this one plus this one plus this one, if you add all 3, you are getting 0.677. 0.677. So if you are getting 0.677 as the total, so you can understand that when it comes to the probability, the required probability, since we have to calculate 1 minus probability x is less than 3, so this value is coming to 0.677. Therefore, the required probability is 1 minus 0.677. So it is coming to 0.322816. 0.322816. But this is not the end of the problem, because the question is how many drivers? You know the probability 0.3228. Drivers, the number of drivers is 500. So the expected number of drivers who will be responsible for at least 3 accidents in a year, it will be given by what? The product. So multiply 500 multiplied by 0.322816. If you calculate, I am just using a calculator. If you just work out, it's coming to around 162, approximately 162. Let us see whether the option is given. Yeah, 14A, the option is given. So 14A, the answer is correct. Okay. So with this, we have completed all the 3 sections, set A, B and C questions. We have taken as much as possible within the given time. I am taking the additional question bank now. In the additional question bank, I'll take few questions. We have around 10 to 15 minutes, max to max, 10 minutes approximately. Okay. So in the additional question bank, number 15, I'll take when the number of trials is large and probability of success is small, then we use what distribution? Trials is large. It can go up to infinity, literally. Probability of success is very small. We use Causal. So 15. So this is the additional question bank, AQB. So 15, question number 15, option number B is correct. I am taking number 16. In Causal distribution, probability of success is very close to what? It is very close to 0 because probability is very small. So 0 is option C. Number 17. In Causal distribution, NP is what? NP has to be finite. I discussed about it. When binomial distribution gets approximated to Causal distribution, N is too big, P is too small, so the product is finite. So NP has to be finite. Number 17, the option is A. Number 18. Okay. In dash distribution, mean is equal to variance. Binomial distribution, no. Normal distribution, no. So Causal is the only option. Because you know in both the cases, mean is equal to variance, which is equal to M. So 18, the option is number C. Okay. Number 22, I am taking additional question back. Probability density function is associated with what? Yesterday's session, I discussed in detail that for discrete probability distributions, we call it, the formula is known as probability mass function. But for continuous probability, for continuous variables or for continuous probability distribution, we use the term probability density function. Here the question is, probability density function is associated with what? Discrete random variable, no. Continuous random variable, yes. So 22, option is B. 27. Okay, 27. The Causal distribution tends to be symmetrical if the mean value is high. Please see one more question coming on symmetry. That is why I completed the symmetry part and the skewness part. The Causal distribution tends to be symmetrical if the mean value is high. The answer is, if the mean value is high, you see how? Okay, if the mean value is high, now this side we show the mean value. If the mean value is somewhere here, okay, then automatically if this is the mean, what will happen? Automatically it will have a curve like this, symmetrical curve. So when the mean value is high enough, but if the mean value is somewhere here, I will draw with a red pen. If the mean value is somewhere here, then what will happen? Then it will have a curve like this. That means it will have a positive skewness. Positive skewness. The red one is positive. The black one is symmetry. So when the mean value is more, then only it will have a symmetry. Okay. So in the case of 27, the answer will be A. Option A will be the right answer. So 27, the option is A. I will go to 54. Next question 54. Because you know in these problems, in these exercise set A, B and C, you have questions from binomial, you have from Causal as well as from normal. So many questions are there, but I am picking only those questions which are related to Causal. Some of them we have done yesterday on binomial, and the remaining ones on normal distribution we will take it up on the last day. Okay. So 54. Quasar distribution is a dash probability distribution. Discrete, continuous, both, none. I hope all of you are clear. No disputes, no arguments. It is discrete. So 54 is A. 55 I am taking up. Dash distribution is sometimes known as the distribution of rare events. Rare events. We started our session with the word rare events, and rare events relates to quasar distribution. So 55, the option is A. 55, the option is A. So here in the additional question bank, 1, 2, 3, 4, 5, 6, 7, 8 questions we have taken. Okay. Now I go into the last part, and that is the MTP question. Only 2 questions are there in the exam, MTP. From Causal chapter, Causal distribution, let us take the MTP question. May 2020 MTP. Okay. The first one is 92. Question number 92 I am taking. 92 and 93. MTP number 2 questions. 92 question says the number of misprints per page of a thick book follows normal distribution, Poisson distribution, binomial or standard normal. You can easily understand, we have discussed in the beginning, printing mistakes, number of accidents, number of customers waiting, number of, say for example, number of comets hitting the earth, okay, number of, say cars waiting in a petrol pump. These are all examples of Poisson. So this one, the number of misprints per page of a thick book, this is also following Poisson distribution. So 92, the option number is B. 93, please see the question number 93 which is there in the MTP. I have seen the same question is there in set B. The question number there in set B, the question number is 15. Same question. The question is, if for a Poisson variable x, f2, please note, f2 is equal to 3 into f4, then what is the variance of x? We have to find the variance, that is m. f2 is equal to 3 into f4. Let us write the probability mass function. Let's do it together. f2 is e to the power minus m into m to the power 2 by 2 factorial. This is equal to 3 into f4. f4 means e to the power minus m into m to the power 4 by factorial 4. So if you break it up, we get e to the power m cancels, e to the power m cancels, m square cancels, this side it becomes m square. So 4, okay, now let us 4 factorial, it becomes 4 into 3 into 2. This 2 cancels with this 2. So I think you are getting, this 3 cancels with this 3. So you are getting m square, you are getting as 4. I think m square is coming to 4. So if m square is 4, then m has to be the positive, not negative. Don't take the negative square root. It has to be the positive square root plus 2. Okay? Because Poisson distribution, number of misprint cannot be negative, has to be positive. So m is 2. So answer is m equal to 2. If you see the option A is the right answer. So 93, option number A is the right answer. And with this, we are completing the chapter on Poisson. So we started first with industry applications, the meaning of Poisson, the history of Poisson distribution. Then we also discussed about discrete, random distributions, discrete and continuous random distributions, probability distribution. We then moved on to discuss about the probability mass function for Poisson. Then we took a lot of, time to discuss on the features in detail, the features and the properties of Poisson. We did solved examples, and then we went into exercise 17. From set A, we have done 8 problems. From set B, we have done 4 problems. From set C, we have done 1 problem. From the additional question bank, I have done 8 problems. And from MTP, the 2 problems which are there in the MTP, we have done. So with this, we are completing this chapter. I am sure you have followed it. And I will take last 5 minutes to discuss about some of the queries which have come regarding the yesterday's discussion on the binomial probability distribution. Now, 92 queries have come, 92 queries and feedback has come. I have responded to maximum of them, maybe around 80-85 have responded, and you will be able to view the responses in ECPL, but I'll take some of them. Kevin Murjaria and Aditi Shah, they have a question. Sir, how can I find in the exam that it is a question of probability or probability distribution? Because both the sums look like the same. Please note, you have seen in all the problems here, it is clearly mentioned that the distribution follows Causal. If it is a question of normal distribution, it will be mentioned that the distribution follows normal pattern. It will be given that the distribution follows binomial pattern. So you will understand which one to use. Even if it is not given, worst case scenario, it is not given. Don't get into panic. You know, if the problem talks about a situation which deals with rare events, that means you have to use Causal. If it deals with situations which are related to success or failure type, right, that means it is dealing basically with binomial. So in this way you will be able to find out, but in all probability the type of distribution will be mentioned in the question. Okay. Mahadevan, I have taken up your issue. Vasant also I discussed about continuous and discrete tandem. Jaisamir Kaur also I discussed about the range, the question which you had. Ankit Sharma I talked about the examples of random variable, continuous random variable which can be negative like temperature and like vertical speed. Okay. Vijayita Sinha had sent a problem if x and y are two independent binomial variables with parameters x, 6 and I'll just give you the hint, Vijayita, for this. I am sure you will be able to follow and complete it. X and y are two independent binomial. Find x has a parameter of 6 and y has a parameter of 4. The other parameter is half and half. It automatically means that x, your question is, what is the probability that x plus y will be greater than 1? We have done similar problems today. So as per the additive rule, for a binomial function, if x has a parameter 6 and half, y has a parameter 4 and half, that means x plus y will have the parameter 6 plus 4, that is 10 and half. So 10 will be the value of n and p will be equal to half. You have to find out x plus y is greater than 1. It means you have to find out the probability 1 minus the probability that x is less than x plus y is less than 1. This is what you need to find out. Or less than equal to 1 rather. Right? Because it is greater than 1, x plus y should be less than equal to 1. So you can easily put the value x plus y, if less than equal to 1 means what? You have to find f0 plus f1. f0 is given by ncx, px, qn minus x. Here you have to put x equal to 0. Similarly, for same equation, you put f equal to 1, x equal to 1. You will get this value and this value. Okay? So, Vijayita, I hope you are following. You will get this value and this value. Say this is P and this is Q. So, add P plus Q. P plus Q if you add, that means you have got this one. And 1 minus this. So, P plus Q. 1 minus P plus Q. You will get the answer. Okay? So, I have given you the hint and I have showed you the way forward. I'm sure you can do it. Okay. Sahil Mehra has sent a question, set B, question number 2. Set B of exercise 7, question number 2. This is perhaps the last one with which we shall end. Okay. Sahil Mehra, set B, question number 2. Set B, question 2. If x is a binomial variable with n equal to 20, n is given as 20, what is the mean of x if it is known that x is symmetric? Now x is symmetric, binomial probability distribution is symmetric when p is equal to half. So q is also equal to half. This is the condition. So when n is given, mean of binomial distribution means n into p. Okay. N is given, n is 20. P is half, then only it will become symmetrical. So 20 into half, that is 10. Answer is 10. Okay. And Aditi Shah, you have sent a question set B. Questions 16 and 17, page 17. Both the questions are in relation to normal distribution, so we will take it up later. And there was one question, I think, from Ananthi in example 17.4, how 60 has come. Okay, this we did last day. I think you remember the question was MTP May 2020. The question was that 4 into P x equal to 2 is equal to P x equal to 2. 4 into P x equal to 4 is equal to P x equal to 2. So please note here 4 into P is given. So the probability that x is 4 is given by n in this question was, no, n is not given. N is given as 6. N is 6. So you have 6 C4 because x is 4, NCX P. P is not given. So P to the power 4 Q to the power n minus 4, that is 6 minus 4, that is 2. This is the value of P x equal to 4. But you have to multiply this with 4 because this 4 is given. So 4 into this. This will give you the probability that x equal to 2. X equal to 2 is 6C2 into P square Q4. Now 6C2 is coming, I think 15. Just let us check. 6C2. So 6C2 this is factorial 6, factorial 4 and factorial 2. So 5 into 6, 2, 3, 15. So this is 15. This side is also 15 because 6C4 and 6C2 are same. So this is 15. But you have this 4 here. So 4 into 15. That is how you are getting 60. So I hope Ananthi you are clear with this. That is how on the left hand side you are getting 60. Right hand side you are getting 15. And okay, Tanisha has sent a long question basically on probability. Tanisha, I will try to take it up. It's an important question, 16.33 regarding probability. I will take it up if time permits on the next day. And the last one is, okay, Khushi Gupta and Sanjana Talekar. There was a question, illustration 17.1. Now 17.1 second part, there is a question. A coin is tossed 10 times, assuming that the coin is unbiased. What is the probability of getting at least 4 heads? Now at least 4 heads means 4 heads, 5 heads, 6 heads, 7 heads, 8 heads, 9 heads and 10 heads. It should go till 10. I will just have a word with Board of Studies and see whether our reasoning is correct or not. I will try to get the clarification from them and get back to you next time. So I think with that we complete today's discussion. Also I will thank some of you who have sent positive comments with respect to the last session. Jyoti Singh, Utkarsh, Anushka, El Kharnar and others. So I think it's about time to complete today. We have done the entire chapter on Causal distribution and I have also taken the questions and the responses for the binomial part. The last session which I am going to have with you is on 22nd, day after tomorrow, when we shall be taking up the normal distribution, which is the only examples probability distribution is concerned. Till that time, thanks for joining. Please go through the problems. Please see the video again and again. If you don't understand the point, any queries do send to me. I'll try my best to give you an answer. If the query is very important, I'll take it up here within the given time and try to solve it. So thanks a lot, dear students, for joining. Wishing you good luck, all the best till we meet on the last day for with you the session which I have on 22nd on normal distribution. Thanks for watching.